I'm going to show you how to do Edexcel A-Level Math, Paper 1 from June 2019, Question 8. My name is Sunil Tanna. I'm a tutor and author. I'm available for one-to-one tuition. I live in Buckinghamshire, England. As you can see, Question 8 is quite a long question. It's hard to show the whole question and the solution on the screen at the same time. So what I've done is I've cut the question up into various parts. So let's get started. Question 8. Figure 2 shows a sketch of the curve with equation y is equal to x times x plus 2 times x minus 4. The region R1, shown shaded in figure 2, is bounded by the curve and the negative x-axis so that the exact area of R1 is 20 over 3. Okay, the first thing to notice is the roots of the equation, which we can look at or figure out by looking at the factorized version of the equation which we're given. So we can see that if y was 0, x would have to be 0, minus 2 or 4, so the roots are minus 2, 0 and 4, and the area R1 will therefore be the integral from minus 2 to 0 of y dx. So what we need to do is expand out these brackets, and then we have an easier form to integrate. So minus 2 to 0, we've got x times, and if we expand the final two pairs of brackets, we're going to get x squared plus 2x minus 4x minus 8. Don't forget the dx here as well. And now multiplying everything by x, we're going to have from minus 2 to 0 of x cubed plus 2x squared, plus 2x squared minus 4x squared, so we could write that as minus 2x squared, and then minus 8x dx. Now we do the integration, and we'll get our results, which will be x to the 4 over 4 minus 2x cubed over 3 minus 8x squared over 2 with the limits of minus 2 and 0. We can put 0 into all of these values of x, and that will come to 0. Putting in minus 2, we are going to end up with 16 over 4. We're going to end up with plus 16 over 3, and then minus 32 over 2. And then if we work that out, remember there's a minus sign in the beginning, that will indeed come out to 20 over 3. Okay, and that completes part A of the question. Right, part B of the question, again I've got it on a new page here, is the region R1 is shown shaded, the region R2 is also shown shaded and bounded by the curve, the positive x-axis and the line with x equals b, in other words this vertical line, where b is a positive constant between 0 and 4. Given that the area of R1 is equal to the area of R2, verify that b satisfies this equation. The equation being b plus 2 squared times, all in brackets, 3b squared minus 20b plus 20 equals 0. Okay, so how can we work out the area of R2? Well, we know that the area of R2, I'm going to move things up a bit so I have a bit more space here, is the integral from 0 to b, and that will give us a negative for the area, so we need to put a minus sign in front of it. The reason being that if we integrate a part of the curve under the x-axis, we have get a minus area, so timesing it by minus in front of it will give us a positive area. So the area R2 will be minus the integral of y dx. Now we can use the integration that we did in the previous part, because the same expression for y applies and we get the same powers of x. So once we do that, we will have minus, and then x to the 4 over 4 minus 2x cubed over 3 minus 8x squared over 2 between 0 and b. Don't forget that initial minus sign in front. Okay, so if we now substitute in b into each of those, we're going to have b to the 4 over 4, but don't forget there's a minus sign, so minus b to the 4 over 4. And then we're going to have minus minus, which will be a plus, 2b cubed over 3, and then we'll have again a minus minus, so a plus 8b squared over 2. That's putting in b, and then it will be minus, putting in b, 0 as a value of x, all those which obviously come to 0, and we know that's equal to area R1, which is 20 over 3. So what we can do is set this equal to this and make them both over a common denominator. I'm going to make them both over 12. So here, times in top and bottom by that by 3 will give us minus 3b4 over 12. Times in top and bottom of this by 4 will give us 8b cubed over 12. Times in top and bottom by 6 will give us 48b squared over 12, and times in 20 over 3, top and bottom by 4 will give us 80 over 12. Times in both sides by 12 will give us minus 3b to the 4 plus 8b cubed plus 48b squared is equal to 80. Now if I bring everything to the right hand side, I will end up with 0 is equal to 3b to the power 4 minus 8b cubed minus 48b squared plus 80. Now I need to verify that this is the same as the expression given in the question. Well, one way I could do is I could multiply out the expression on the left hand side of the question and see if it comes out to the same thing. The other way to do it would be by polynomial long division, which is what I'm going to do. Now what I can do here is I can first of all see b, I've got b plus 2 squared, so I could work out what b plus 2 squared is. So b plus 2 squared would be the same as b squared plus 4b plus 4. And if I divide this expression by b squared plus 4b plus 4, I should get the other brackets on the left-hand side of the equation. So I've got b squared plus 4b plus 4 divided into 3b to the power 4 minus 8b cubed minus 48b squared. I'll write in a b term because when I'm subtracting it's easier if that column's not missing, so I'm going to write in 0b and then plus 80 here. So how many times does b squared go into 3b to the power 4? It goes in 3b squared times. If I multiply each of these by 3b squared, I'm going to get 3b to the 4 plus 12b cubed plus 12b squared. And now I can subtract 3b to the 4, subtracted 3b to the 4 is nothing, minus 8b cubed minus another 12b cubed is minus 20b cubed, minus 48b squared minus another 12b squared is minus 60b squared. I've still got 0 b's and I've still got 80. So how many times does b squared go into minus 20b cubed? I'd have to times it by minus 20b. So minus 20b goes here. Times each of these by minus 20b is going to give us minus 20b cubed minus 80b squared and minus 80b. And then subtracting here, minus 20b cubed minus minus 20b cubed is going to be 0. Minus 60b squared minus minus 80b squared, so minus 60b squared plus 80b squared is going to be 20b squared. 0b minus minus 80b is the same as 0b plus 80b, so it will be plus 80b, and then 80 take away nothing is still 80. How many times does b squared go into 20b squared? It goes into 20 times. So timesing each of these by 20 is going to give 20b squared plus 80b plus 80, and again you can see those two are the same, so there's no remainder. So in other words, this times this makes this, so that's proof of it, yeah? So I could, I guess if I could maybe write another line, but I think I've shown it. Okay, for part C of the question, it says, explain with the aid of the diagram the significance of the root 5.422. Sorry, I missed a part. The roots of the equation 3b squared minus 20b plus 20 equals 0 are 1.225 and 5.442 to 3 decimal places. The value of b is therefore 1.225 to 3 decimal places. Okay, so if you go back to the diagram, which I will put here for a moment, yeah, you'll see 1.225 is here. This root was 4, so 5.422 is over here somewhere. Now remember what we did was we this area was a minus, and we put the minus in front of the integral to make it a positive. So what would happen is if we were to integrate from 0 to 5.422, we would have this area minus this area being equal to R1. So the way I will show that on the diagram, yeah, is there's R1, right? There's 4, there's 5.422. Right, let's call this, that's area R1. Let's call that area A. That's area B. Yeah. So area A minus B is equal to area R1, or 20 over 3. Another way of saying that, if you rearrange that, is if you you could rewrite this as saying area A is equal to area R1 plus B, if you take minus B over the other side, which would tell you that, for example, that it's when the area above the graph, the area above the x-axis is equal to the area below the x-axis. So there's several different ways that you could say that. I'm sure as long as it's a correct conclusion that explains the significance of 5.422, you would get the marks. And that completes question 8.